Here we are in section 4.3, real zeros of polynomials. And so this is a really kind of nice way to figure out how to find all the zeros of polynomial. Or at least all the rational zeros. There's other ways, and you'll learn other methods. And you're going to find that most of your math career is how do we find zeros of a function? Just mostly what you do, right? Because where zeros occurs, where all the where most of the stuff we need to look for. Like when we take a derivative, that's where our min and max value is. It's where our function changes when we're doing the second derivatives. Zeros is where it has other values and all that. So this is just what we do in math. Anyway, so the rational zero theorem says if we're given some polynomial that has integer coefficients, then then every rational zero of this polynomial is of the form p over q, right? Where p is the factors of a naught and q is the factors of a n. So the best way to do this is just to crunch through this. So let's look at this. All right, so p here is equal to 2, q here is equal to 1. And so here if we list out all the possible things, so we'll have plus or minus 1, plus or minus 2, right? Because here I can have 1 times 2, or I can have negative 1 times negative 2. So you just list them as plus and minus 1 and 2. Here, for q, we have is equal to 1. The factors here are plus or minus 1. I can have 1 times 1 or negative 1 times negative 1. If we put these together as all possible, right, that gives me 1 over, or 2 over 1, negative 2 over 1, 1 over 1, and negative 1 over 1. Or in other words, negative 2, negative 1, 1, and 2. So these are all possible zeros. And so one thing you can do, and I'm just going to show you, you can do this, but I'll show you what we really do in practice, is you can just plug each one of these in. So let's plug in negative 2 and just see if it's a 0. So negative 2 cubed minus 3 times negative 2. So everywhere I see an x, I'm just going to plug in negative 2 plus 2. So this becomes negative 8 plus 6 plus 2, so that's 0. Oops, my thing would draw. Here we'll have p of minus 1, so this is equal to negative 1 cubed minus 3 minus 1 plus 2. Well, this ends up being negative 3 plus, or negative 1 plus 5, which is 4. Sorry, if I could do math. Here, if I have 1 cubed minus 3 times 1 plus 2, that's equal to 0, because I'll have 1 minus 3 plus 2, so that's 0. And then p of 2 is equal to 2 cubed minus 2 minus 3 times 2 plus 2. So this is 8 minus 6 plus 2, which is 4. Okay, so here we have 2 zeros, right? Our 2 rational zeros are here. But we don't really know how to factor this completely, so this is mainly just for show. This is just for show. I just want to show you how to do this. What you're really going to do is you're going to do synthetic division. Remember how we did this? And you're just going to start testing numbers. And I'm going to just start with 1 because 1's the easiest, right? And also know it ends up being a 0. And so here, if I did synthetic division, I get 1, 1, which gives me 1, which gives me also 1, which gives me negative 2, which gives me negative 2, which gives me 0. And so what does this mean? This means that x cubed, hold on, let me grab it, minus 3x plus 2 is equal to x minus 1. Remember, what you put here, you have to negate, right, when you pull it out. And then here I'll have x squared plus x minus 2. So x squared plus x minus 2. Okay. And then here I can just factor that normally. So that'll be x minus 1. And here I'll get x minus, I'll get x plus 2, x minus 1. Okay. And so now we know our factors, right? And that matches what we found out. We have one of the zeros -2, one of the zeros is 1. In fact, the 1, it has multiplicity of 2, right? Remember, multiplicity is how many times that 0 occurs. This occurs twice, okay? So this is what we're going to be doing in order to factor. So I'll let you guys copy that down, and then we'll work on a harder one. And then we'll do a couple more from there, okay? So as you guys finish copying down, and we reiterate what we did. So we took the factors of a naught, which is 1 and 2, plus or minus, and the factors of q, or an, which we call q. 1, we write all possible combinations of it, of p over q. We get this. Here I'm just showing you this, but this would really be your first step. This is really your first step right here. Is just pick one, see if it factors out. And then once it factors out, you have a smaller polynomial which you can perform the same. You can refine more factors, or you can just keep trying the factors you have. Okay. All right, so let's do this again. All right, so here, so here we have a 2 and a 6. So here p is equal to 6, q is equal to 2. So let's look through this. So here I have, and I want to list all my factors. So this would be plus or minus 1 and plus or minus 2, plus or minus 3, and plus or minus 6. Okay. So here we go. So we have 1, 2, 3, and 6. Okay, I'll grab you after class. Just remind me. And then here we're going to have plus or minus 1 and plus or minus 2. So you just take all, so here we're just taking all the integer factors, right? Things that factor cleanly into this, and you just hit plus or minus. All right, so if we ran through this, let's go ahead and just see, what does this imply? Well, this implies so let's go from, let's just do the ones first. So I have plus or minus 1, plus or minus, so over 1 will give us plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So 1 over 1 is 1, 1 over 2, 2 over 1 is 1, 3 over 1 is 1, 3 over 6 is 1. All right, 1 over 2 is new, so it's plus or minus a half. So we need to add that as a possible factor. 2 divided by 2 is 1, so we don't need to add that. 3 divided by 2 is new, so we need to add plus or minus 3 halves. And 3 divided by 2 is 3. We already have that. Okay, so this is all the possible zeros. All right, so what do we end up doing? Well, I just start at the top and work my way through. That's literally what you do if you had to do this by hand. Okay, and so here I'm just going to start with 1. Why? Because that's the easiest one to do. 1. So here we'll have our factors. 2. Oops, there should be a square right here, guys. Please add that square. 2, 1, minus 13, and 6. All right, so if I do 1, I'll just go ahead and synthetically divide it. So it's 2, 2, 3, 3, minus 10, minus 10, 4. Okay, so this isn't it, right? So this isn't a factor. 1's not a factor, so I don't have to worry about 1. Let's try minus 1. Okay, so we have 2, 1, minus 13, and 6. And so here we'll have 2, minus 2, negative 1, minus, or positive 1, multiplied by the negative 1, minus 12, 12, 18. Okay, so -1's not a 0. So what do we do? Just go to the next one. And you just kind of crunch through this. It's kind of terrible this way. I'm not going to lie to you. But if you had to do it by hand, this is how you would do it by hand. Now, does your calculator do something like this? No, it probably uses a different algorithm. I'm not going to lie to you. So this turns into 5. So 2 turns 4, 5 turns to 10. 10 gives me -3. -3 times 2 gives me -6, which ends up being a 0. So we have a factor. Ding, 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 ding. We win, right? And so here I can write this as x minus 2 times 2x plus, or 2x squared plus 5x minus 3. Okay. All right, so now so where are we at here? So here we want to find all the possible factors of this. And let's just go ahead and run the algorithm. You could just factor this normally, right? But let's pretend we wanted to run this algorithm again. So here, if I wanted to factor this using the algorithm, the algo, which just means just test all these algorithm. We don't need to test here. We can throw away plus or minus 6. I'm going to say plus or minus 6 needs not to be tested. And why don't we need to test it? Because it's not a factor of this, right? And we don't need to check 1 or -1 again, since we already checked it, right? Already checked. Okay. And I'm going to do the algorithm for a very specific reason. That way you just get used to how you would do it for larger ones. I mean, here you'd factor normally, right? But let's just do the algorithm. So we know it's not plus or minus 1. We know it's not plus or minus 6. But, hold on, let me zoom out. We do need to check, but we do check 2 again. So we check 2 again in case of a double root. Okay, so you do check 2 again, and so here we just have 2, 5, and -3. And so if we check 2, so we get 2, 4, 9, 18, 15. So nope. And then you just keep checking down the list. And I just keep going down the list. And that's why I always put the fractions at the end. I want to check those last. So here, let's go ahead and do this. So here we'll have 2, 5, -3. So if we check -2, we'll have 2, -4, 1, -2, -5. So now we'll check 3 next. And here if I check 3, so 2, 5, -3. Now, do I know the answer? Yeah. But I want to show you how you would do it if you did it organically. I'm just going to save us time. I'll check -3. You check 3, it doesn't work. But you check -3 and it does, just because I'm out of space. That I'll cheat for a second. So let's check -3. So this becomes -1. This becomes +3. And therefore, this becomes 0. So this works. And then here we can have x minus 2, x plus 3, because of the -3 here. And then here I have 2x minus 1, which we can end here, right? Then here we can end because here we have our zeros. Our zeros are 2, -3, and a +1/2. Now, if we did a +1/2 way up here, it would have worked out, and we could have factored that out first. Okay? So this is all there is to this section. We're going to do one more problem just to demonstrate it. Some of your homework problems is just list out all these long numbers, and then after I teach the section, I'm going to show you the homework for 5 seconds to kind of see what the computer wants for you, and then but I'll do that off camera, obviously, because I cannot I cannot display copyrighted material and then post it on YouTube. Just one of those things I shouldn't do. All right. If I posted this somehow on a private school website, then I could do it because it's under the Fair Use Act somehow, some way, I think. I don't know. I'm not a copyright lawyer. All right, that should be plenty of time for everyone to copy this down. All right, so let's do one last one. Let's find all the factors of this. And so here I have P is 10. So you just look at the last one, it's 10. So my factors here, and then here I have another one of 1. Just make life easy for us. And so here, if it's this, so this is plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So do we really need to check? Just this up here. That's all we need to check, right? Because only if the leading coefficient's a 1, you just check the factors of 10 or the constant term. Okay. All right. So I'm gonna let you guys pick which ones I will do. So anyone want to guess which one of the zeros is? All right, so we'll do 1 minus 5 minus 5 plus 23 plus 10. 10? All right, let's just try 10. So if 10 is one of the zeros, so here I have 1, I'll get 10, add up the minus 5, I get 5, I get 50, I get 45, I get 450, I get 47, 30, and I get 4,730, which gives me 4,740. So no, that's not a factor. You just guess them, right? Here, I'll have you guys pick one more, and then I will choose stuff that I know is correct. Just, I want you to, feel. So pick another one. Anyone want to pick another number? Minus 2. All right, so minus 2. All right. So here we go, minus 2. So here I have 1, minus 2, minus 7, positive 14. Add that up, I'll get 9. 9 gives me negative 18. Add that up, I get 5, and 5 gives me minus 10, which gives me 0. So hey, we scored a factor. Yay. So here's one of the factors, and so I'll just write this as x plus 2. Which is usually what I do, and then I'll factor this out. So this is x cubed minus 7x squared plus 9x plus 5. All right. And notice here, once we factored out this negative 2, notice here we can see that both 10 and negative 10 aren't factors right anymore. Because if I redid this again, all I need to do is check. In fact, here I can safely check either 5 or negative 5, right? Or 1. We already checked 1. I'll give you a hint. Negative 1 doesn't work. So notice here, I can redo P and Q. And I'll actually redo P and Q for this, right? So P is 5, Q is 1. So what do I get? I get plus or minus 1 and plus or minus 5. And plus or minus 1 here. And so all I need to check here is this. And so once you factored it out, it should simplify and make your life easier. All right, so I don't need to check 2 again, but I can check. So let's just check 5. And here, if I check 5, I get 1 minus 5, 9, 5. And here I get 1, 5 minus 2, minus 10, negative 1, negative 5, and 0. So this works out. And so just so I have room, because I know I need it, I guess I'll write it here. So I have x plus 2, x minus 5, and then I have x squared minus 2x minus 1. All right. And then here we can just try to factor. From here you can just try to factor. But you're going to notice this doesn't, so factor. But this one doesn't factor cleanly. Let me zoom back in so I can write English and not make it look like garbage. So here we're just going to factor this. But it doesn't factor cleanly, right? So most of the time once you get it to a quadratic, you guys know how to handle quadratics absolutely. So it does not factor cleanly, not factor cleanly. So if it doesn't factor cleanly, what does that mean? The quadratic formula, right? So here, I'm going to move this up here, and we're going to try to factor this. Oops, let me give myself a little bit more room. So here, x is equal to 2, so negative b plus or minus the square root of 2 squared, or negative 2 squared, doesn't matter. I'll put it in all the same, negative 2 squared minus 4. A is 1, C is negative 1, all over 2a, which is 1. I simplify that out. This is 4 minus, this is positive 4 minus a negative 4, so that becomes 2 plus or minus the square root of 8 over 2. So this becomes x is equal to 1 plus or minus the square root of, I can pull out a 4, so this becomes 2 square root of 2 divided by 2, so it's just square root of 2. And so if I want to factor this completely now, I have x plus 2, x minus 5, and then I'll have x minus 1 minus the square root of 2, and then I'll have x minus 1 plus the square root of 2. Okay. And so here I can state my zeros. Because here it would be x minus your 0. And so if it's 1 plus the square root of 2, that'd be 1 minus, or x minus 1 minus square root of 2. So my zeros are the following. It is 2, it is minus 2, it is positive 5, and 1 plus or minus the square root of 2. Okay. All right, so that's how you zoom out so you can see most of it. So that's what you're doing this one. You take a polynomial of any size, and we're going to factor it completely down. That's all we're doing. All right, so